In this video, we're going to summarize some basic probability rules. We did some exercises in class where we experienced some of these rules, but now we're going to make it a little more formal. So one of the most basic probability rules of all is that any event A has to have a probability between 0 and 1. So no probabilities can ever be larger than that. So for example, we might say that 30% of students at Williston are day students. So that's a percentage, but really it's a proportion that is a number between 0 and 1. So the way we say this formally is that the probability of any event A, so probability of A, must be a number between 0 and 1. So that example is 30% day students at Williston. Okay, another rule is that the sample space has to have a probability that is equal to 1. So if we include all possibilities in our description of an event, then the probability of any of those things happening has to add up to 1. So for example, we might say, so here's kind of how we say it formally, but if I say, let's imagine the randomly selecting a student from the Williston population, and that student could either be a day student or a boarding student, and that includes all possibilities. So the probability of day or boarder has to be 100% or 1. We've seen this before, the definition of probability. The probability of any event A is a ratio of the number of outcomes corresponding to that event over the total number of outcomes in the sample space. Now that sounds very abstract, but what if we were just saying probability that we draw a face card on any single draw of one card from the deck. So we've seen a lot of examples like this. We know that there are 12 face cards in a deck and there are 52 total cards. So that's just definition of probability. Here's a rule that we saw in some of the examples we worked with in class. We were looking at dice and we were looking at the probability that something doesn't happen, and we discovered that that could be found by taking 1 minus the probability that it does happen. So for example, probability that we don't draw a face card would be 1 minus the probability that we do draw a face card. We might make this more formal, and there's a little symbol that we use to indicate that we're finding the complement of something. A complement can be thought of as the opposite of something. So this is the probability of FC. We don't draw a face card. Could be found by finding the 1 minus the probability that we do draw a face card. So 1 minus 12 over 52 would give us 40 out of 52, and we should notice that 40 is the number of cards in a deck that are not face cards, and 52 is the total number of cards in the deck. Okay, last basic rule that we're going to take a look at is the addition rule for events that are called mutually exclusive. Now this is a term we didn't get to talk about very much. So mutually exclusive means that there's no overlap in the events. So I could either find an observation that is one thing or another, not both. So an example might be looking at the event that a person is either a day student or a boarding student. There's no one in between. There's not one person who is both a day student and a boarding student at the same time. Now, if I were to ask, what's the probability that I randomly find a student at Williston who's taking statistics or calculus. Now, those events would not be mutually exclusive because there are some students who take both calculus and statistics at the same time. So the way when we discover that two events are mutually exclusive, then we can add their probabilities. Okay, so let's just do a side example before we jump into some other examples. Day or border. And remember, we're thinking about randomly selecting a person who meets those characteristics. So I could say the probability that someone is a day or border would be the probability of a day student plus the probability of a boarding student. Right, and I'm going to just guess at those probabilities. I could think of them as percentages, or I could think of them as proportions, and those would have to add up to 1. Okay, so that's how we use the addition rule for mutually exclusive events. We add probabilities. So the next video will go over some examples.